Okay, let's have a look at question 8. A particle P moves with constant acceleration. So if it's constant acceleration, that means we need to use SUVAT. At time t equal to 0, the particle is at O, the origin, and is moving with velocity 2I minus 3j meter per second. And t equal to 2 seconds, P is at point A with position vector 7I minus 10j. Part A showed that the magnitude of acceleration of P is 2.5 meter per second square. So if magnitude of acceleration is what they want to show, so to find the magnitude, so first we need to find the acceleration vector. Yeah, so we find the vector first, and then work out the magnitude. So we have origin O as the starting point, and then at t equal to 2 seconds is at point A. So if we let this one to be the start point, and then this one to be the end point, then the velocity at this point to be u, then this will be v. And we have velocity at origin is 2, -3. And we don't know the velocity at point A, but we know the position vector is 7, -10. So r is equal to 7, -10. And then we know t is equal to 2 seconds. So we have t, we have u, we want to work out acceleration, and we have the position. So it should be SUVAT. So first we have current position is equal to the initial position plus the displacement. Yeah, so that would be the formula. And then current position is 7, -10. And then original position is just the origin, so 0, 0. And then the displacement. So we know u, we know t, and then we want to work out acceleration. So we have to use s equal to ut plus half at squared. So simplify that, we have 7, -10, 0, 0, just 0, 0. So you can just ignore that. And then u is 2, -3, and then time is 2, and then plus half times that a, which is what we're trying to work out, times by t, which is 2, and then square. So 7, -10 is equal to 4, -6, and then plus 2 squared is 4 times half is 2, 2a. So then we have 2a is equal to minus 4, -6 for both sides. 7 minus 4 is 3. 10, -10 minus -6 should be -4. So acceleration vector will be 1.5 and -2. So magnitude is equal to square root of 1.5 square plus -2 square. So let's put in the calculator. That should give us the correct answer. So 1.5 square plus -2 square, that's equal to, yes, 2.5 meter per second square. So part A is done. Okay, let's have a look at part B. At the instant when P leaves the point A, the acceleration of P changes. So P now moves with constant acceleration 4I plus 8.8J. So because after it leaves A, the acceleration will be different. So we now use point A as the start point, and then moves to point B. We know the acceleration is equal to 4 and 8.8 meter per second square. And then we call, because we're looking for the distance A to B, so we let B to be the endpoint. And at the instant when P reaches the point B, the direction of P is northeast. So every time when they're talking about the direction of motion, we we need to look at the velocity vector. And then when they say it's northeast, so we have to compare that to this vector. So let me show you. So this is north and this is east. So northeast would be the diagonal line. Yeah. So it's just a vector which is parallel to 1 and 1. Yeah. So remember that every time when it's in northeast, we need to compare to 1, 1. And then every time when it's a direction of motion, we have to use the velocity vector. Yeah. So we need to use the velocity vector of B. So we need to get B at some get the V at some point. Yeah. So because we know acceleration and we want to work out the time, and we need to use the velocity vector. So V, A, T. So we just need to work out U, so which is the velocity at point A. So to work out the velocity at point A, we need to use what we did before, because in the part A, we know everything apart the velocity vector of point A. So we can use that to work it out. So V is equal to U plus AT. So in this case, O is still the starting point and A is the end point. So A would be V in this case. And then U would be the velocity at point O, which is 2 negative 3. So we have 2 negative 3 plus A, which we already work out, 1.5 negative 2, and it takes 2 seconds. So times by 2. That will give us 2 negative 3 plus 3 negative 4. That's equal to 5 negative 7. That will be the velocity at point A. So which means the velocity at point A here should also be 5 negative 7. It just, in this case, A is our starting point, B is our end point. We call the velocity at A to be U in this calculation, and the velocity at B to be V. So don't get confused. It's all about what's your starting point and what's your end point. So if you start from O and at A, then O would be U, the velocity of O, and the velocity at A would be V. But if you start from A and then finish at B, so the velocity at A would be U, the velocity at B would be V. So since we're looking for the velocity vector at B, so V is equal to U plus AT. So U is 5 negative 7, and A is 4, 8.8. And then T is just T, we don't know. But if we combine them, that would be 5 plus 4T and negative 7 plus 8.8T. Because the direction of motion is northeast, so that means the velocity vector has to be parallel to 1, 1. Yeah. So that means 5 plus 4t, negative 7 plus 8.8t is parallel to 1, 1. So if two vectors are parallel to each other, so that means there must be a scale factor between them. And then the scale factor between both I component and J component has to be the same. So for example, like so 2, 3 is parallel to 4, 6. How do we know they are parallel? Because 4 divided by 2 is equal to 2. And then 6 divided by 3 is also equal to 2. Because the scale factor for both I and J component are equal. That's why they're parallel. So 4, 6 were not going to be parallel to 8 and 10 because the scale factor for the I component is 2, but for the J component, then that would be like 5 over 3. So they are not the same. So therefore, they are not parallel. So because we know they are parallel to each other, so that means the scale factor for both I component and J component should be exactly the same. So then we use that to set up the equation. So 5 plus 4t divided by 1, that will give us the scale factor for the I component. And then negative 7 plus 8.8t over 1, that would be the scale factor for the j component. Because those two vectors are parallel, so those two scale factor must be equal to each other. Then we just have to solve them. So divide by 1 stay the same. So we can just let 5 plus 4t equal to -7 plus 8.8t. And plus 7 for both sides, minus 4t for both sides. We have 12 equal to 4.8t. So t should just be 12 divided by 4.8, which is 2.5 seconds. Then that would be the answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.